Welcome everybody to week 7, day 2, and today we're going to be talking about landscaping, we're going to be talking about foliage, we're going to be talking about water, and we might even get into projectile weapons as well. So, modern versions of Unreal Engine have a water engine in it that is pretty decent looking. It's pretty decent. My daughter actually made this. I didn't make this. Mine would probably have the river connecting down into the lake. But let's go through this. So first thing you need to do is go to Edit Plugins. So you go up to the Edit menu, choose Plugins, and then under Plugins just search for Water and enable Shallow Water and Regular Water, and it'll probably ask you to reboot if those are not currently enabled. And what's cool about that is that once you have it installed, you can kind of make lakes and ponds and waterfalls and oceans and things like that really easily inside of Unreal Engine. It's a pretty straightforward process. You can see all the tiling on this texture here. I probably want to redo that one. Okay, so let's get into it. So if you come over here to the palette, the water palette, and search for water, this will give you all the different options that are part of the water plugin. You have a tree coming by to cut back your tree for your solar. Yeah, no worries, no worries. So there's a couple different options here. The most obvious would be doing just like a lake. So I'm going to drag that over to, I don't know, here or something. And boom, there's a lake. Simple as that. And you can see that it cuts into the landscape. So it actually interacts really nicely with the landscape. In order for that to happen though, modes, landscape. When you make your landscape, you have to have edit layers turned on. Let's see, if I click here and select the landscape, let's pull this over here. After you've made the landscape, you have to have this checked here, enable edit layers, and that allows the water to sort of modify the landscape. So what happens when you do that is when you drag the lake out, you can see it actually moved the landscape down. It actually cuts into the landscape in a kind of an interesting fashion like that. So in order for that to work, you have to have that checked. Don't forget that. You'll be very baffled when water doesn't work if you don't have that selected there. And that's can be done either when you first make your landscape. There's a tick box, which doesn't show now, called Enable Edit Layers, or after the fact, you can just click on the landscape from select mode and make sure that is ticked. Okay, so we've got our water thingy-me-bobby here, and all the water things are controlled using these curved lines kind of things called splines. And so what a spline is a, and you can actually see how it, do you see how it cuts through the landscaping? It's kind of cool. A spline is a curved line, and so this is your standard drag up, drag down, kind of dealio. But there's also these little control points on the lake, and these are spline points. And spline points kind of control the curve, the shape of the. Does the water use a gravity function? Your character movement does. So I'll get to that in a bit. So if you want to control the shape of the lake, you can click on these individual spline points here. And what you'll see is that you've got not only the ability to move the spline point around, which controls, like where the edges of the lake are. You can also see you've got these things like this. And that actually adjusts sort of the angle or the curve of the coastline, I guess you might call it. Okay? And if you want, you can add more spline points to the lake and have a more interest. This is just a triangle, basically, right? So if we were to come back here, we could right-click and choose Duplicate Spline Point, and then let's see, we move this one kind of that way, and I can adjust this. I can move it this way, and you can see how I can like change the shape and all that kind of stuff. It's kind of cool, right? So you can make these really interesting curved, borders for the lake and stuff like that. And you do that by, again, you select it, and you can select any of the spline points on there by just clicking on them, and then I found the easiest way is just you can right click add spline point, or you can click on an existing spline point and just hit duplicate, and all sorts of options on that. You can also use this little control panel here to kind of like go through the different spline points. Let's see, it's like next spline point, and so you can just add as many as you want and create a very interesting curved coastline or whatever it is you want. Now, and that's true for the river. You can see over here my daughter added a lot of spline points. She pulled this one up a little bit, this one up this one. She pulled this one up a little bit to create a little like waterfall effect, and then she added splines to create kind of a curved river going this way, and then she kind of really needs like one more to, like if I come in here, maybe I can do it for, click there, right click, duplicate spline point, pull it out and down like this, and let's see here. Kind of want it just kind of going into the lake, you know what I mean? And then you have to kind of play with this stuff because it'll look really garbagey if you don't do it right. There's a lot of options, which I'll get into in a second, on how to like make these things look right. But overall, the water, see, it's too far deep into this. The water manager will actually have the water from the river flow down like this into the lake, and you see how it just kind of blends together really nicely. So the lake itself just has waves and stuff like that, but the river has moving water. But if you look at it, like there's no like clear boundary where it's just like, here's the end of the river, here's the beginning of the lake. It actually has a water manager that like it will actually kind of figure out like the interface between it and stuff like that, which is really cool. Let's see, let's rotate you down like that. It's a little better. Point here. See the spline curve is like facing up that way, so let's tilt it down a little bit. Now this part is kind of weird. Maybe like that. Yeah, we got a little bit of a problem with the water going uphill here, but yeah, we can play with that. It doesn't look quite as garbagey now. So if I unselect it, you can see that the water is kind of coming along this way. And then it flows down the thing here, and then it kind of, we got this weird artifact right here that I'm going to need to take care of at some point, but it flows right into the lake and goes in there. So, does water have a gravity function? So if we were to play this game, where are we? Oh shoot, yeah, I don't have the character working correctly. I'm going to have to go to a different template because this is currently a work in progress. This one, last semester. So your character for a third-person template has different movement modes, and there's a thing on your character blueprint as this loads called the character movement right here. Right here. Okay. So main character. So this is my character here, and if you look at it, it's got this thing called a character movement attached to it, and that has the rules for how the character moves in different circumstances. Let me minimize my face, and you can see we got gravity here, max acceleration, friction, crouching height, mass. When you're walking, step height. That's like the if you encounter like a ledge, how big a ledge can you step up onto, and it's like almost half a meter, I guess, 45 centimeters. How steep a slope it could go up, ground friction, walk speed, crouched walk speed, etc., etc. jumping, falling, how much air control you have when you're falling. Because in most video games, you can actually control yourself in midair, right? In Mario Brothers, you jump off a ledge and you can push backwards and pull back your jump a little bit and things like that. It's unrealistic, but it's gaming, right? And then if you scroll down, you can see that there is a character movement for swimming. And so there's a swim speed and there's a buoyancy. Buoyancy is basically anti-gravity. So if that's what you're asking about, Pada, the depending on how you set buoyancy, where'd you go? Depending on how you set buoyancy, you can have your character just fall through water like he's made out of iron, or you can have him float. And so I have buoyancy set to 2, which means that in water he actually will bob upwards. And so if we were to run this game here, and come over here into the water zone that I've set up, you'll see that he sinks down and then it bobs up to the surface. So, and now I'm in swimming mode, right? Because I'm in water. And so the you don't need to do anything special really. It'll just automatically, because I have a lot of buoyancy. Now if I were to turn the buoyancy down to 0, my character would simply fall through the water, right? So if I come in here and set the buoyancy to 0, that means that it will basically, fall through and thunk. And so now I'm swimming, but I'm not floating upwards at all. Okay. And so when you're underwater, it turns on the swimming movement, mode. And got some goblins coming at us here. Die, won't you die? Yeah, I must have turned off the damaging function on them. Anyway, so that's water. So if I were to click on this water over here, let's see, I have what's called a physics volume. Right here set up. And so if you go to the left-hand side here, you can say physics volume, and you can drag one of these things out. And basically what a physics volume does, it's invisible, you don't see it, but what you can do is you can say that when somebody is inside of this physics volume, and you can like scale it out to however big you want, and move it wherever you want. So what I did was I moved one of these physics volumes like under the lake, basically. What I did was I said when you're in this physics volume, you're swimming. It's a water volume. So that's how I did that. This isn't this thing here isn't actually using the water plugin. I just took a plane and I put a water texture on it. Just like this one here. This is literally just a plane, and I made a lake texture. Or maybe I'm just using the default lake texture, but the default lake texture uses that panner that I was showing you last time. And what it does is it adds together different water textures at different speeds and different directions, and does some macro texture variation, things like that. So it makes this nice little like water surface here. So it's just a plane. You fall through, and when you're underneath the water, it turns on the physics volume, so it turns on the swimming of the player. And so I have anti-gravity. Let me put that back. Anti-gravity. Okay. Maybe try 1.5, see how that works. I don't bob up to the top quite so quickly. So the buoyancy is a little bit lower now, if you see that. So not bobbing up quite so quickly. Okay. So that's basically the water system. I have here, this is water system, this is a ocean. So oceans, if we come over here, water, the basic options are island, which creates like a chunk of land out in an ocean. So if I were to drag that out over here, then, wait, that's way too high. Put a island out here. Why are you so high up? It might not work on the other one. Islands create bodies of land in water. A lake is a like that's what I showed you earlier. You can add a little bit of water to the. It's way too big. These things are so big. There. So you can add a little. This isn't interfacing very well. So you can add little bodies of water to your landscape. Ocean is designed for this, so you can basically, if you have your landscape, the ocean will basically eat away all of the outside parts of the land and surround the world in ocean. And so it's kind of nice. That way you don't have to worry about edges of the world and things like that. You just drop an ocean on your world, and then you, if I select this, you can see the different spline points on here. And you can, move the edges of your island around and stuff like that. So you can kind of have a nice little interesting island surrounding your main level. It looks really nice too. A river is used for, obviously rivers. So I could drag that out here. And you can see it will, once it compiles the shaders, we'll see water will start appearing here. And we can control these spline points to dig into the world, and you, like you saw earlier with Hedgehog World, you can have basically water following a path, making waterfalls and things like that. That's the important thing. Yeah. So, yeah, that's basically it. So, drag the things out and drag out a lake, drag out a river, and just control the spline points like I showed earlier, and just make a little something. That'll be your homework for Tuesday. Just do a little bit of water on that. And like I said, there's lots of options. So once you click on your ocean or whatever, you can play with all these different options. And sometimes it takes a while to kind of get it looking good, because like you can see here, like it creates these weird boundary effects that are really kind of weird and jaggedy and things like that. It tries to do like an okay job. Like you can see here, the landscape gets cut down like a beach would, and it kind of does an okay job at that. And these things are controlled by like these things here. So you can have a fall off angle of like 10 degrees, and then you see how that changed there, right? Fall off width, fall off angle of 0, just wiped out all that stuff. It's interesting. So it kind of controls the edges and things like that, edge offset. And so you can control all the different boundaries and how it cuts in and things like that, blur the shape. See how kind of curl noise, curl displacement, all these kinds of things, smooth blending. It kind of yeah, and basically you just sit there and just play with these different things and just kind of see how it looks. Affects landscape off, right? It doesn't even appear. Right. So, yeah. So basically, whenever you make a lake or a ocean or something, like it's gonna cut into your landscape, and you have to control kind of like the edges. The edges are usually really kind of gnarly looking, stuff like that. So just play with these things, and channel edge offset. You can just sit there and look at it. Just 50. Just sit there and just kind of play with it until it looks right. Okay. You can see the edge of the island has been cut off. This is the ocean. It's like kind of cutting into the edge of the world here, and this thing here too. And trying to get it looking just right does actually take a while. Okay, any questions about that? Actually, that looks a little better. Yeah, that one actually looks a little better. Now the waves themselves can be messed with as well. So there's two different kinds of waves that it comes with. By default it does water waves. Gerstner waves kind of look better, so I kind of suggest you switch to those, and they kind of create more realistic looking waves. And you can really spend hours just messing with this, trying to get exactly the right kind of waves that you want. Number of waves 10, make it a little smoother looking. 2, right? Nice. Calm day. 100 waves probably looks like garbage. There's too much going on here now. So that minimum wavelength, maximum wavelength, minimum wavelength of 10. You can see the wavelength is a lot smaller now, and so you get these like high frequency waves in there. Undo. Wavelength fall off. Minimum amplitude 4, max amplitude of 80. So if you up the amplitude, then the waves get bigger. And so by controlling the wavelength, the amplitude, there's a range, so they're not always the same size. You can just sit there and kind of play with it until you're getting kind of the mood that you want for your ocean. So now it's kind of a peaceful ocean. Dominant wind angle, let's make it 90 degrees. So you can control the direction the waves are moving, basically. Small wave steepness, 0.1, 10. So yeah, all of these things are really fun to play with and just really mess around with until you get values you like. Underwater post-processing settings. So when you go under the ocean, you see how the camera changes colors, right? So it does have, if I turn that off, you can see it won't change colors, right? If you turn that on, it'll automatically add what's called a post-processing volume to the underwater area. And so post-processing settings, lens, let's see, color grading, temperature, let's see, shadows, midtones, highlights, mask, where's the, somewhere inside of here, film, rendering features, somewhere inside of here, it's setting the color to be blue. Tinting, yeah, okay, maybe. You can add a vignette effect. A vignette effect will darken the edges of the screen. You see that? That's also pretty common for underwater. It's kind of vignette, so the edges will darken. Kind of cool. Yeah, so basically all of that is under the post-processing settings. So when you go into the ocean, it will automatically do that. And you can see now that the corner of the screen is now darkened, right? Because I added the vignette effect. Yep, okay. So have fun with that. Water is a fun system. It's new. It's I think within the last year or so they actually added it. It's still in beta, I think, but pretty cool, and just a lot of fun to play with. It is kind of wonky, like you saw on my daughter's map. Like there's these weird artifacts. Like you'll just get water like kind of bulging out, very unrealistically at times. But you know, you kind of have to sit there and play with the spline points and turn them and rotate them and move them, and kind of it does take some finesse to kind of get it looking good. But it's really cool. It's really neat. So have fun with that. Okay, any questions about that? Nothing has been said on chat in 15 minutes. So please say something on chat just so I know that you are still alive. Okay, all right, cool. So now we are going to make a projectile weapon. And we already have one in this one, but maybe I'll just start from scratch. Spring 22. There we go. So last time we talked about hit line, trace line weapons, hit scan weapons. So for hit scan weapon, you basically give a starting point and an ending point to the bullet, and the engine will tell you the place that you hit, and then you can like inflict damage there or cause an explosion or something like that. So what do we got in our world right now? We have no clicks. Okay. So on this version of my thing, I don't have any action keys bound, so I'm going to do what we talked about last time, which is you go to project settings input, add a new action mapping, for attack. I'll make an attack. 3 T's in there. Attack 1. And attack 1 will be mouse left click, like that. And I will add another action mapping for attack 2. And that one will be right mouse button. So if you click on that and then right click, it'll just pick it for you. It's nice. Okay, so we got that. Action mappings are set. Save. Now I'm going to come over into my third-person blueprint. Blueprints. Third-person character. This is kind of like your main. This event graph here is kind of like the main program for your thing. Do I need VR? Nope. Deleting that. Some of you deleted too much stuff out of it, so just don't delete the stuff unless you kind of know what you're doing. Input. Touch. Don't care about you. Delete. Action jump. Look up. Turn. Look up. Turn right. Okay. So we are going to come in here and we are going to add a attack. So I'm going to type in attack 1. So I right clicked, chose attack 1, and now every time I left click, it's going to call pressed. And every time I release, it'll call the release if I want to do something like that. So we could do a charged attack. Does that sound interesting to you all? Like maybe have a weapon where like, have you played Halo? There's like a plasma pistol where like you hold it down and it starts glowing, and when you release it, it does an overcharge attack. Do you want to do something like that? That could be kind of fun, I think. Right. Alex, is there a charge weapon like that in Destiny? Where you like, the longer you hold it down, the more damage it does?
Yeah, they're called fusion rifles.
Okay, yeah. Same company, kind of.
Linear fusion rifles, which basically it's like a bunch of bolts that come out of your or like yeah, a bunch of bolts that come out of your gun kind of. But linear fusion rifle, it's just like a straight like one bolt comes out.
And it does more damage the longer you hold it down.
Not really. It's just like charge to fire.
I see. So you have to charge it, and then
Yeah,
if
to
you, what
fire.
happens if you release too soon?
Nah, it just doesn't fire. It like goes kind of like that.
Sad, kind of sad. Okay, why don't we do that? That sounds kind of fun. Yep. So when we press the left mouse button, we're going to start charging, and when we release it, we're going to fire. If it's been, how long does it take, Alex, to charge?
It varies. There's a bunch of different archetypes like high impact or like adaptive or rapid fire, but they all vary.
Give me a number
I'd
like
say
a
the
second.
most common one would be like maybe like a second to half a second. I don't know.
Okay, let's make it a second for easiness. So whenever we do coding, I always start off with just having it print something. So print string. When we click, we're going to print charging, and when we release, print string uh, releasing, right, or something like that, firing. Charging, charge, charge. This literally doesn't matter. Charging. Okay. So compile, save, and this is kind of how I do development. I always like just making sure that everything works first. So when I click, you can see right here, I click and it says charging, and then when I release, it says firing. So I click, it says charging, release, firing. Cool. All right. I don't have landscape, do I? Solve that real fast. Material. Do I have a landscape here? I don't. Grass. Let's make a grass. Okay. There. Looks not quite as bad. That material there is just hideous, though, isn't it? Starter content. Materials. That's really bad. Steel. There we go. There, that's not as hideous as before. Okay, cool. Okay, click, charging, release, firing. You guys with me? I've verified that these things are actually taking place. Okay, and if you want, you can make it so that like if you hold down Control while you click or something, it does something different. Who cares? All right. So what I want to do is I want to sort of just write down the current time. Like when I click, I want to just write down the current time, and when I release, I want to see if it's been a second. Does that make sense? Like, so how do we do that? So I'm going to drag out from here, and I'm going to say get time. Okay, get current time. Let's see, get world. Oh wait, get current time. No. Get time. Get date. Get hour. Time span, Oculus library, let's see, get time in seconds since the world was brought up for play. Yeah. This doesn't actually attach to a white pin, which is why it didn't show there. So what I'm going to do here is when I press the thing, I'm just going to get the current time, and I'm going to save this. So what I'm going to do is I'm going to save this as a variable. And this is the huge learning point for today. These are all just CPP functions. They are, but they're in blueprints. And so it's nice because it tells you what the type is. Like if you mouse over the type, it'll tell you it returns a float, and the float is how many seconds has gone past since the game was brought up. And so, cool. So I want to save this into a new variable. And base turn rate, don't care. But over here, there is a button where you can make a variable. So I'm going to make a variable. It's like in algebra or whatever. And I'm going to call it click time or something like that. And next to it, there's a little red hyphen chicle kind of looking thing. I'm going to change that to float. And then what I'm going to do is I'm going to drag that out and choose set. So I'm going to set the variable called clicked time to the current seconds, like that. So all I do when I click is that it just writes down the current time into this variable. And there's actually a faster way of doing that. Let me delete you. Yes. I can actually right click on this pin here and choose promote to variable. You all see that? This is a very common thing we do in Unreal Engine. So if there's anything that you want to just kind of like save as a variable and like write it down and use later, right click on the pin, choose promote to variable, and then over here you just have to give it a name. So I'm going to call this clicked time. And that way the type is set properly. It's a float. Floats are green. Pada, does it make sense to you? We're just basically, when we click, we just write down the time. That's it. Okay. And then when we release, we want to get the time, the current time, and subtract it from the click time and see how much time has gone past. So when we release, we are going to, let's see here, we're going to get click time. So you just drag it out, choose get. So when we release, we are going to do a subtraction. Let's see, let's do this. Type subtract, minus key, float minus float. So let's see here. So let's see, current time, get time. So we're going to get the current time, and we're going to subtract the last time we clicked, and that's how long it has been since we've held down the mouse button, this variable here. And what am I going to do? I'm going to print this. I'm going to print the string. So that is what I'm going to do. So when I click the mouse button, I write down the current time. When I release the mouse button, I take the current time, subtract it from the time I wrote down, and I'm going to print that, not as the duration. Nope, nope, nope. Not as the duration. What? Just right click, break all pin links. Thank you. I'm going to drag the floating point value from there into the string. This converts a float to a string, and it's going to print just that number to the string, to the screen. So we come in here, hold down click, and release 1.9 seconds. Click and release 0.2 seconds. Click and release 3.2 seconds. Click and release 0.04 seconds. Okay. Hold down click and release 5.2 seconds. Okay, working. Always double check to make sure your stuff works. And if you want to print if you want to do print string and you have a float, what you have to do is drag from the float into the string, and you'll see that it automatically will convert the type. It'll go from a green pen to a fuchsia pen for you. Okay. So cool. We know that works. So now we need to say if the difference between the two is greater than like a second or something like that. So if the thing is greater than a second, fire. If not, play a sad pew, pew, pew sound. Okay. And so we do that with a branch. So I could hold down B for boy and click, B for branch and click. I could do it that way. Or I could just drag out from here and type if, which gives me a branch. A lot of different ways of doing this. The branch is going to take a Boolean, and the Boolean means something that is either true or false. So what we need to do is we need to compare the output of this subtraction here. Remember, this pin here holds how long it's been since we clicked. And so what we need to do is compare this. We need to say, is this greater than or equal to 1 second? Okay. So what I'm going to do is I'm going to just attach it like that. And so what this is saying is if it has been 1 second or more since I clicked, then true will take place. Print string, and I'm going to go fire. And if it has not been a second, then I'm going to print string sad. Okay. And again, I like just using print strings just to make sure everything's working. I really like just really incrementally developing a little bit at a time. Hold down click and release. Fire. Fast click. Sad. Sad, 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 sad. Hold down click and fire. Hold down click and fire. Cool. Everything's working. Okay. So Then I come in and delete the print strings. You see how this works? You see the development process? You do a little bit at a time. A little bit at a time. Always testing, always making sure it works. Because Unreal Engine is, it can be annoying to work with. The same concepts as actual code, absolutely. Unreal Engine, sometimes like you do something and then just like nothing happens, and then you just don't know why, right? Like let's say you built this whole thing out here, but you never actually made like the input binding correctly, right? Like maybe you didn't have the attack bound to the left mouse click. You'll just be sitting there clicking and just like nothing's happening. There's no anything. And then you don't know if like your branch is wrong or like this is wrong or like anything's wrong. You just like, I don't even know what's happening. And it's just like frustrating, right? And then you can do things like you can come in here and like right click on it and set a breakpoint, which means if we ever get here, pause the game and let me know. But when I do the development, I just like incrementally building a little bit at a time because there's so many different ways that Unreal Engine can go wrong. And usually when it goes wrong, it just goes wrong silently and you don't even know why. You're just sitting there like, why is just nothing happening? And it's super frustrating. Can we put a note that the attack one is linked to left click on that screen? Yeah, it's probably a good idea. So at this point, once we're kind of getting a lot of stuff here, select all of it and hit C. C is for comment. And then I'll be like left click charge. What did you call it, Falcon, Alex? Charge fusion.
Fusion rifle.
Yeah, charge fusion rifle.
Do you want me to show it to you?
Please don't sue. Okay. Ah, dang it, lost it. Left click. I got the concept. Charge. Okay. So, okay. So now we got all that. If nothing happens, we'll just play a sound or something. Recorder, voice recorder. Wah wah. No, where? No. Nothing? Nothing? Ah! No. Hey. Good job, Microsoft. You have made recording a sound a in-depth procedure. Wah, wah. Wah, wah. Okay, there we go. So you opened in file location. Oh, it's an MP4. Oh, why do you not just do a WAV file for me? This is getting far more involved than I wanted. Okay. So I just saved a sound recording there. It's in M4A format. Unreal Engine only takes WAV file format, so I need to search for M4A to WAV converter online, and we come here. And we drag the file over to here, and we say convert to WAV, and then we wait, and done, and download, and save onto the desktop, close, and come into a third-person example, go into Bill, import, Hedgehog World. No, we're going to import the recording 13.wav. Oh, it's super quiet. Okay, it's in there. It's in there. Right click, create a sound cue out of that. We're going to call this Sag. And this thing's kind of quiet. Kind of quiet, so what I'm going to do is I'm going to add a volume modulator, oscillator, override attenuation effects. I could just do this volume multiplier 5. And then I can adjust the pitch. Alright, maybe we want to adjust the pitch. So there we go. Sag is done. And then, so if we fail here, we will play sound 2D. 2D means it just plays inside of your speakers with no, it's not in the world. It's like it just plays in your speakers. And we're going to select here Sag and do that. So boom, ba-doom, ba-doom, play. There you go. So quick. Okay, there we go. So we have the sad noise. Mungo, please no sue. What's interesting, renaming extension and changing it. M4A is a different file format. Unreal Engine only understands for sounds WAV files. It's, in my opinion, one of the dumbest things about it. Unless that's changed recently. You basically just need to convert everything to a WAV file. So this is the Sag WAV. And then once you import a WAV file, you can right-click on it and choose to create a queue from it. And the queue actually allows you to do things like adjust the volume and things like that. It's not the raw file. It controls how the raw file is played. And there's all sorts of interesting things you can do with it over here, which more or less lecture for another time. But you can have it like randomly adjust the pitch and randomly adjust things like that, which when I was making a game that had bullets, I had like a bullet, kind of like the bullet coming out sound or a bullet gunshot sound. And what I did was I made it so that it would randomly increase the pitch or decrease the pitch by about 10% each time, so that it doesn't sound like you're playing the exact same wave file every time. So it's like pa, 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 pa. And there's just that little bit of variation, because in real life, it's never exactly the same sound. And so using sound cues, you can add like inherent variability in the sound, which is pretty cool. And a lot more stuff as well. That's a lecture in its own. Okay, so good. We got that. We got the sad sound. Then sound engineering. Yeah, like you can be a sound engineer in the games industry. Like I met a guy. That's what he did. And I don't know if I want to go off on that tangent too much, but like it's a kind of a fun career. Making sound effects for games involves, you got to be kind of creative, because you don't have like a aircraft carrier that you can like go and like record the sounds of, so you have to like, okay, how do I get a sound of like an aircraft taking off, and you think about it, you're like, well, that kind of, all right. So this guy, he went to his toilet, he flushed his toilet and he held the microphone in the toilet, ran it through a bunch of audio effect processing things, and next thing you know, it's an airplane taking off. Pretty fun. You'd get bags of sand and like hit them, and sound effects for movies are cool. Yeah, they're called Foley artist, Foley, and it's kind of cool. I have to say, it's kind of a cool career to get into Foley, Foley, and then of course, yeah.
For like bones breaking and stuff, they'd like crack a bunch of sticks of celery.
Yeah. Or for Cloudy with a Chance of Meatballs, I think they got like some wet socks and were like slapping them, and that's the sound of the burgers hitting the ground and stuff like that. It's kind of cool. Okay, so we got that. Now we need to say, all right, now if the shot goes off, I don't want to make another sound effect, but let's create something. Okay. We need to first make something to create. So we're here in Bill. Let's make a new blueprint class. This is going to be an actor. An actor is just your generic thing that can appear in the world, right? Just an actor. And this is going to be called Projectile. So what does the projectile look like, Alex, for the fusion rifle kind of thing? Is it a ball? A spike? What is it?
It's like a bunch of bolts that just come out, like a bunch of, I don't know, but like a shotgun. Imagine shotgun pellets, but like they're long, like lines. I don't know how else to explain it. I can show you.
Yeah. Okay. Yeah. Sure. Show me the shot. Or you just screenshot it for me. I'll try to rip it off. Bungo, please don't sue.
I'm live streaming if you want to look at it.
Welcome to the light.gg patch 2.1 run.
Okay, whatever. All right,
That's just a website to view all the perks and stuff
Okay.
of the guns.
Are you playing video games during class?
No. Yes. Maybe.
Maybe. All right. I see. Okay. Okay. So it's okay. Okay. All right.
Yeah, that's pretty much.
Yeah, I got you. I got you. Okay. Supercharged. There it is. It's kind of like, yeah. Okay. I got you.
No, yeah, I gotta end the stream.
Okay. All right. All right. Okay. So maybe we'll make it like a cylinder or something like that. Okay. So new blueprint. This will be called Fusion Shot. And so basically, when we click, we want to produce a projectile that's going to then fly through the world. It kind of looked like a hit scan weapon. Is it hit scan, Alex, or is it actually a projectile?
But in the file, they do have travel time, but
Okay.
recently it was increased from 999 or 99 to 9999.
Oh wow. Okay.
999.
So
So
okay.
they do have travel time, but it's very, very like minimal.
Yeah, I gotcha.
To the point where it's almost hit scan. Yeah.
Yeah. Yeah. It kind of.
I
Okay.
think that was siders. I could be wrong. I don't know.
Okay. So this will be the projectile. So what I did was I made a new blueprint, and then inside of the blueprint, I went to add component. I typed in cylinder. I'm adding a cylinder. Red is the direction of forward for these things, so I'm gonna rotate this thing 90 degrees that way, and I'm gonna scale it down a little bit, maybe not. Where you go? There you go. I don't know how big this thing's actually gonna be. Maybe we'll scale it that, and maybe like that, maybe something like that. Okay. And then for the material on it, we're gonna, I don't know, it's kind of like a purple color, huh? Probably don't have anything out of the box. We'll do steel, why not? Okay. Compile, save, and then let's just drag this thing out and just, okay, that's a big shot. Okay. That's a little bit too big, I think, so let's come back in here and scale you down a little more. If you want, you can always just do the scaling here. So, 0.1, 0.1, and 0.5 maybe, something like that. Compile, save, drag it out. Yeah, that seems about what we were getting in the world in Destiny, right? It's kind of about right. Okay. So there's our shot, and then, okay, all right, cool. So what we're gonna do is when we shoot, we got our player here. Let's make a point that the shot is gonna come out of. So I'm gonna add to the, mesh here. I'm going to add a component, and I'm gonna add a, just gonna add a scene component, and this is gonna be just called firing point. So firing point here is, I'm just gonna drag it kind of like here, and it doesn't have a mesh. If you see over here, there's no actual drawing thing on it. This is just purely just a reference of like where the bullets are gonna come from. Okay. So what I did was I clicked on the mesh, and then I added to the mesh a scene component, and that just gives me the ability to kind of just name a point in space. Okay. And so no matter where the mesh rotates to, watch this. If I rotate this, the firing point will rotate with it. You see that? Because it's a child of the mesh. You see how it's like parented to it? so it's kind of indented like that. That means no matter where the mesh moves, the firing point is going to move with it, and it will always be about, I don't know, half a meter in front of the, what was that? Yeah, maybe a meter in front, something like that, of the character. And the reason why we do that is so that now when we fire, what we're going to do is we're going to drag firing point out here, and we are going to get its location. We're going to get the location of firing point because that's the place where we're going to make the projectile. And what we're going to do is we're going to say spawn actor from class, like that. Okay. And I'm going to split the transform into, too big. Let's get you out of the way. All right. So what I did was I dragged out from the branch, I chose spawn actor from class. The class I'm going to spawn is fusion shot, the thing I just made, like that. And the whenever you make something in a world, there's three things you have to set. First is the location. If you don't pass it anything, it'll be spawning at the world location, which will probably confuse you. That's the most important, is the location. The second is the rotation. You want it facing the same way you're facing, right? A very common bug that I used to make was I would shoot and the projectile would come out straight, but if I turned to the right, the projectile would still be facing north. You know, so no matter which way I was facing, the rockets would always come out facing north because I'd forget to set the rotation properly. So what I'm going to do is I'm going to set the location that it spawns to the location of firing point here, and then let me just show you this. It'll be funny. So if I do this and fire, oh, it's just playing the sad sound. Okay, all right. I have to charge first. Sorry. And then I do this, and there it is. So you see how it spawns like on that spot right in front of me? Now if I move around, charge and fire, you see how it's still, no matter which direction I face, charge and fire, no matter which way I face, the thing always comes out facing north, right? You see that? So we got here, and I can't run into it. That's funny. These things are just like now impossible barriers that you can't get through. This actually could be kind of fun. Let's see if I can do this. Yeah. Let's see if I can jump up on him. Yes, you can build your own stairway. But you see how the problem is? Like they're all facing the same direction. They always face north, basically. So we need to fix that by getting our direction, our forward vector. So the arrow component here is the direction we're facing, or you can just get the direction of the mesh. There's a lot of different ways we can do this. Let's see if I can grab you, and it doesn't like it. Get forward. Let's see if this works. If not, we might have. Arrows are mostly supposed to be just like decorative, but that's a rotator. That's a vector. So I need to convert to rotator. Let's see if that works. Doesn't like that. Yeah, I'm not supposed to use the arrow component. Yeah, let's just try self. Let's see if that works. Nope, doesn't like self. Let's use the firing point. Why not? If we have firing points forward vector set properly, then this might work, or it might not. Okay. Nope. Oh, well, it's coming out a different angle now. It's always at 90 degrees. Okay. So if we come back into the third person character here and go to viewport and click on firing point, I bet what we'll find is the red arrow, the X arrow is forward. That's why the shots are coming out sideways. So what I'm going to do is I am going to simply rotate it 90 degrees to the right, You can see the red arrow is now facing forwards. So now when I get the forward vector out of the firing point, it will have the new shot facing in the same direction. Okay. I think. Let's make sure. Okay. There we go. There we go. All right. Didn't hold it down long enough. There we go. All right. So you can see we're now creating shots that are that are pointed in the direction we're pointed. And if you think this is the first time I've ever had shots come out sideways, like I said, it's a pretty common thing. And so the way that you get the direction you're looking is you just kind of look at your viewport and you see how the model itself is facing the wrong way. Just look at the red arrow. The red arrow is always your forward vector. So that's why I rotated the firing point here so that the red arrow is actually in the direction we're looking. And then I could simply grab the forward vector out of the firing point, and then I dragged that into the rotation transform, and then it will do the conversion for you, this thing, whose name I obviously cannot remember. It does it for you. The third thing is the scale. I think the scale on this is fine. I might want it to be a little bit smaller, but it's kind of fine for now. Okay, so this thing here is creating a new shot. Now you might notice this is a very boring shot because it doesn't do anything, right? It doesn't have it just sits there. it never goes away, right? So we need to give it a velocity, right? We need to give it a velocity, and we also need to make it so when this thing touches something, it like explodes or something, right? So simulate physics, probably not. Simulation generates hit events. So I clicked over onto the fusion shot thing here. And what I'm going to do is I click on the cylinder. The cylinder is the thing we care about. And let's see if this has anything that matters. Nope. Okay. So on the projectile, scroll down, and there is an option here for collision. And so what you do is you turn that on. If you turn that on, then every time somebody touches the cylinder, it will generate a hit event. And we'll just leave this as the default. Sometimes you have to mess with these collision settings as far as what you can actually run into. But basically on the fusion shot here, I'm going to go over to event graph. I'm going to just leave those alone for now. And I'm going to go to hit. So when the cylinder hits something, it is going to do this. As always, I start off with print string, and so I'm just going to say hit. Hit. And we'll just begin with that. And a lot of times, like you'll play the game and like just it won't. It just won't. So watch. If I run into it, it should say hit. Ha! There we go. Okay. So when we run into it, when this projectile runs into anything, it's going to call this code here. So all I want it to do is just, I think just explode for now. So we're going to just play a sound at location, at the hit location. That's the place where they touched it. We're going to play the explosion sound, and then we will spawn emitter at location. So let's just do a little fireball kind of thing here. Explosion fireball. The location is going to be the location where we touched them. And then after that, we are going to just destroy the actor. So this is a pretty common thing. So like when you have a projectile, like a rocket launcher or something like that, it's pretty common for it to have a hit on it. This is one of the three primary ways we interact with the world. One is trace line, one is touch, which is this, the other one is thinking. And so this interaction method is like when the thing travels through the world, it's not moving yet, but when it travels through the world and hits something, it explodes and it destroys itself. And we could also add in like a lifetime, maximum lifetime to this thing, but that's not as important. Okay, so we play a sound, we spawn an explosion fireball, and we just delete ourselves, and there we go. So this is a It's not inflicting damage yet, but there you go. So there's our projectile. We walk into it, and it blows up. Okay. There's our projectile. There's our projectile. There's our projectile. Yep. So that's, you know, your basic thing. The other thing we're missing, of course, is inflicting damage, right? But we haven't gotten into damage yet, and we probably won't have time. For today, I'm going to talk for about, I don't know, 10 minutes more, and then I'll let you guys go. So, event hit, play sound, spawn emitter, destroy yourself. Okay. That's your basic rocket launcher touch. But the main thing we need to add to this to make it interesting is a speed, right? We need to make it go. So this blue pin here is the projectile we just made. We need to do something like set velocity, set physics, linear velocity. On the projectile, set all physics, linear velocity. Force or add impulse. Yeah, we don't have physics enabled though. Witch Queen, nice. Let's see here. You are currently not simulating physics. Let's do that. Let's turn physics on, turn gravity off. Actually, let's start with gravity on. Let's just see how that works. Okay, so hold down attack, and it blew itself up. Okay. It's blowing up on us now. There we go. So, okay, so it has physics now. All right. And we want gravity off. We want it to just sort of ignore gravity and fly forwards. Ignore radial impulse, apply impulse on damage, apply impulse on damage. Replicate physics. For damage to apply physics. I don't think we want that. Okay, let's do that for now. All right, so now we can add physics, add velocity, or we could add impulse to it. To the projectile. And we are going to add impulse. Let's see if this works. May or may not work. Let's see if it works. There we go. It did work. Of course it worked. Why wouldn't it work? Okay, so I'm holding down attack, release it. There. So we've got a very slow moving projectile that if we were to catch up and run into it, it would do that. And if we're running forward while shooting it, it blows up on our face. We might want to spawn it a little bit further in front of us so I can adjust the spawn location, the firing point here. And pull that forward a little bit and see if that helps with our firing problem. There we go. But I'm still running. I still run faster than it, so I can still catch up and run into it. So that's a problem. We need to let me delete this. Okay. We don't need you either. Okay. But there you go. Okay, so we got the projectile in. Good. Let's just come in here and add even more impulse. So what I did was I just took our forward vector, multiplied it by 1,000, and said add impulse to it. So it's basically kicking it forward in the forward direction using the physics engine, rather than setting the velocity directly, which we could have done. Instead, it's using a physics accurate way of pushing it forwards, which I don't know if I prefer it or not, but it seems to work. So let's just add a little bit more impulse to it like that, 4 times the impulse, and okay, fine. There we go. There we go. All right. Not quite the, I know. Not quite the 999 speed that we had in Destiny 2, but yeah, good enough. You know, we'll kick it up a little bit more. 6,000. Let's shoot the. See if we can shoot the. There you go. Not terrible, not terrible. I can still run into it. There you go. So there we go. So that is a projectile weapon. Any question? Kind of cool, right? Like, so in short, you bind a input action. A lot of times you'll simply just, when you click, you just immediately spawn an actor, but what I'm doing here is charging. You have to charge for a second. If you want that second to be like a variable, I could right click on this and choose promote to variable, and I'd call this like charge time. And then maybe you could get like a power up or something that reduces charge time, or maybe this is set by different fusion rifles and things like that. Like some will have a greater charge time than others. Also the charge time down to like 0.5 seconds seems a little more fun that way. But as a variable, you can adjust it on the fly without having to recompile everything. Looks good, pretty understandable. Okay, so yeah, so charges when we release, if it's been more than a second or half a second now, then it gets the direction we're looking. It gets the location of firing point. I guess I don't need you twice. If I wanted to do, I could do it like that. Okay. So it gets the location of the firing point. I added a scene component to the to my player just as a way of marking a point in space, so that this is the point the bullets come out of. And we'll learn more about sockets later, but this is kind of an easy way of just saying, here's a point in space, it's got a name, it's called firing point. And then we can grab its location to spawn the new shot there. We can get its forward vector to see which way is forward out of there. And then we use the spawn actor function. The spawn actor function is very important. It creates the projectile, and you have to make the projectile first before you do that. That's why I kind of hopped over into this thing here. And it's going to make that fusion shot projectile. It spawns it at the location of firing point. It spawns it pointing in the direction that firing point thinks is forwards. It spawns it at regular scale. I should probably set myself as the owner. This thing's kind of tangled up right now. Clean it up later. So I'm setting myself as the owner of it so that reroute node. If you double click on a wire, you can do what's called a reroute node like that. So you can like kind of have the wires kind of not get in the middle of your way. Yeah, so I'm the owner of it, and the reason why you want to do that is for, like, if you get a kill, you want to give credit to the owner, things like that. So this thing here spawns a projectile at a certain location, at a certain rotation, at a certain scale. Then it returns a reference to the new projectile. And so you can do things with it, like give it a velocity, right? And so I'm using the add impulse thing. Another thing we could have done was like set velocity on it and just directly giving it a velocity, which, arguably is easier to do. I don't know. But what I did was I just took our forward vector, the direction we're looking, multiplied it by 6,000 to create 6,000 units of energy pushing the thing forward, and then the physics engine does the math and launches the projectile in that direction because it does have a mass for the cylinder here. It is 2.7 kilograms, or about 5 pounds. So I turned off gravity. If I put gravity back on, then that could be kind of amusing, I guess. I don't know. Okay, let's see if I can shoot it from here. See that? It's more like a grenade launcher now, right? So it kind of like flies out. Kind of like... Not as fun, in my opinion. Not as fun. So I'm going to turn gravity back off. So you kind of have to hop back and forth between your projectile and your character, right? Because you're spawning a projectile, so you have to go over into the projectile, and then the last step, again, is on the projectile. When it hits something, you want it to remove itself from the world. And then you also usually want to have a lifespan on these things. Maximum lifespan. I don't see it on here right now. You might, somewhere on there. I've done it before. You can make it so that when you spawn something, it'll automatically despawn after like 10 seconds or something. Because if you shoot a projectile and it doesn't hit anything, it'll just keep flying forever, right? And so you can kind of hose your game performance if you allow people, like I had a crashing bug in my game. People would do this. They would look straight up and just fire a bunch of projectiles straight up. And they would just keep doing that until the server crashed. Because the server would become overwhelmed with the number of projectiles it had to track. They never deleted themselves, so the server would crash. And so it's important when you create something to have kind of a timeout on it. And we can show you how to do that some other time. It's not the most important thing, but you can basically make it so that the shots will, like, after 10 seconds will delete themselves. So if a rocket hasn't hit something in 10 seconds, it's probably not going to hit anything. You know what I mean? It's probably just off the edge of the world. So, okay, that is our class for today. Your task for Tuesday is just to make water. The first part of the class, pretty easy, pretty straightforward. On Tuesday, we will go over damage and how to actually have weapons that actually damage things and stuff like that. And then your assignment for Thursday, when I'm out of town, is to actually implement an actual weapon, have the ability to shoot the snowman or something, either with a projectile weapon or a hit scan weapon, have it have health, have its health decrease, have it explode, stuff like that. So once we do that, you got kind of the basics of a game, right? You have the ability to make a world and obstacles. We haven't talked about monsters yet. That's the next big topic. How to make monsters, like you saw in the world from last year. Goblins are running around after you and stuff like that. But once you can make weapons that can damage things, and you can build worlds and have materials and all that stuff, then you're basically in business. You know what I mean? Like, you're already like halfway to actually having a professional game. So, yep, that is our lecture for today. I don't see any questions on Discord, so yeah, thanks for coming out. And on Tuesday, we have Unreal Engine installed in the lab computers. So yes, we will actually be able to do Unreal in class. That's good. That's awesome. All right. I'll see you guys next time. Peace out. Save all. Always remember to save all. All right. Peace.